Hi, everyone. A warm welcome to today's webinar. It's a pleasure to have you all join us for what promises to be an insightful session on transforming enterprises with intelligent 5G standalone core, AI-powered optimization, network slicing, and smart orchestration. I'm Rohina Chawla, and I will be moderating today's session. A few points before we begin. We will share a recording of the webinar with you all to revisit at your convenience and share ahead. Also, we recommend that you use headphones for a better experience. Lastly, if you have any questions or clarifications during the session, please park them in the Q&A section, and we will take them up at the end. In today's session, we will explore how Amantya's AI-powered 5G standalone core is transforming network operations, how the advanced solution optimizes resource allocation, enhances network efficiency, drives real-time analytics, and enables predictive fault detection, all essential elements for achieving seamless connectivity in today's fast-evolving digital landscape. We will also explore some real-world use cases for a better understanding of AI's role in optimizing 5G core functions and learn how features like AI-powered load management, intelligent UPF optimization, and self-healing networks are shaping the future of smarter, more resilient networks. To take us through the session, joining us are two seasoned experts from Amantya who have been deeply involved in the development of the company's next generation 5G solutions portfolio, including the intelligent 5G standalone core. Gaurav Saini, Head 5G and Communication Practices at Amantya, and Ankur Bharadwaj, Senior Director 5G and Communication Practices at Amantya. So without further ado, let me hand over the floor to Gaurav. Over to you, Gaurav.
Thanks, Rohina. I believe we can start now.
Yes.
Perfect. So, welcome everyone for this exciting webinar with transforming enterprise with our intelligent 5G SA core. So quickly, today we'll run through in terms of, I'll talk about a bit of company overview before we delve into the 5G core. Then we'll introduce our 5G core capabilities. Then we'll talk about the key services and how we have built AI into those services and what are the use cases which are powered through our 5G SA core in further deployments. So as a snapshot of a company, and Amantya is an organization which is actively working in all the next generation technologies, be it 4G. We started with 4G and now 5G. Then robotics, AIML is another practice we have extensively working on. Then embedded, IoT, GIS, and cloud platforms. As an organization, we are 6.5 years old. We were established in 2018, and we have been working with large tier 1 carriers, OEMs across the globe for various use cases, for various products and services for our customers. Today, we have grown up to 800 engineers across India, US, and Canada. And then in terms of our presence, like I just spoke about, that we are serving tier 1 carriers, tier 2 carriers, OEMs, MVNOs in US, UK, India, and even other regions of the across the globe. Then we also have offshore development centers for our US tier 1 customers here in India. Then when we talk about solutions, we have developed some in-house solutions which we leverage as accelerators or our products for various customer deployments and use cases. And then in terms of partner ecosystem, we have active collaboration with Red Hat, Dell, IBM, Intel, Kamara for their APIs, Napatech for their SmartNIC deployments, and BSNL for the private 5G deployments across India. In terms of our own solutions, so we have a AI-enabled 5G core, which we'll talk about in detail in the further slides. It's a 3GPP compliant 5G SA core ready for enterprise use case deployments. Then we have a UPF user plane function as a part of our 5G core with capability up to 200 gig throughput, and even the support of 4G, 5G, and Wi-Fi convergence. The same node supports the data plane functionality of 4G and even Wi-Fi integration. And then we leverage our solutions for private 5G deployment across the globe for various use cases with various partners of ours. We are actively working on development of various testing portfolios, and we have the solutions deployed across tier 1, tier 2, and OEMs, large OEMs across the globe for RAN automation testing, light RAN or a small scale RAN testing, then core end-to-end core feature testing, and then even Wi-Fi automation for basically the Wi-Fi mesh network testing. We have done various webinars across our testing platforms and solutions, which we can go back and look at our previous videos. I won't go in that much depth about those, but let's delve into the 5G core part for our today's webinar. So when I talk about 5G core, so today my 5G core is release 16 compliant, and all network functions we have here are working as a microservices format where each network function is independent, plug and play architecture. We have integrated our core in a single holistic deployment, or even each network function has been integrated with third-party core itself. So they are simply 3GPP compliant, open interfaces, interoperable. Now, in terms of deployment, we talk about the solution supports deployment on a simple bare metal or even on a private or public clouds, be it AWS, GCP, Azure, or OpenShift deployments. Now, in terms of capability, if I talk about, the core can support up to simultaneous 100K sessions and a throughput per UPF deployment of up to 200 Gbps. Now, we support both Intel-based deployments using Intel cards, or even smart NIC deployments using Napatech card. We have integrated with Napatech card, which enables low latency, where all the packets are routed through the smart NIC, and which reduces the latency of processing at the UPF itself. Now, primarily, if I talk about key features for deployments, we support network slicing, where 8 slices can be used or deployed in the core. All the QoS functionalities are there. Then even UPF relocation, UPF branching, or ULCL functionality, which enables the edge UPF deployment. And the standard HTTP2 plus SSL based node communications are there, which enables high security, which 5G provides. In terms of another UPF, we talk about location-based services, and then redundancy is another part. We understand that when we deploy on enterprises, there are various enterprises where network reliability plays a key role. So redundancy is something we have developed and for our solution, which gives an up to 5 nines of reliability over the network. And earlier I was talking about our converged node. So when I talk about my UPF, even though I'm talking about a UPF in a 5G per se, but it's the capability it has that it supports the data plane from a 4G and even Wi-Fi. So what we have done is in our UPF, we have merged the SGW, PGW functionality. We have merged the N3IWF functionality into same node. So when we, as an optional feature, if you deploy a UPF and you have a private 4G existing 4G network running, the same UPF can handle the data plane for existing private 4G. Or on top of that, everybody would already have a Wi-Fi network deployed, and they start deployment of a private 5G network. That's where our UPF comes into play. The existing Wi-Fi network integration to the private 5G network happens through our converged UPF. So UPF would also be through N3IWF, would be able to handle the Wi-Fi data user plane on the same device, and even enables the mobility from Wi-Fi towards the 5G through our node. And in terms of today, when we talk about 5G network deployment, everybody must have heard about how the APIs are playing a key role in terms of monetization of the networks. So we support NEF as a part of our 5G core. And in terms of through NEF, a lot of use cases can be enabled. A lot of application automation can be enabled, where application can ask 5G network to add a slice, change the QS level for a user, or various different use cases. On top of that, what we have done, I'll talk about how AI is built into our core, but in terms of primarily NEF, we have built in AI agents in the solution, which can actively influence the 5G core behavior through a NEF APIs. That's another interesting feature we have built in. And we believe because of the way APIs and the agentic AI architecture is evolving in the network, this will play a key role in the future networks. And in terms of industrial private 5G feature set, we talk about local breakout. We'll talk about the Ethernet PDU functions in the further slides. Then application specific QoS, and then policy rule enforcement in terms of different use cases. Because each use case, if I talk about deployment, would have a different requirement. If I talk about a smart factory, Ethernet PDU can be something where the bridge mode needs to be deployed or used. Then we talk about local breakout. If I have to do a reduction in OPEX and I want to leverage the private network, that local breakout plays a key role. Now, we have all those 5G core feature sets. If I'm talking about intelligent feature sets using our agentic AI, what we are building is in our core, we are building an agentic AI feature set where the agentic AI enables smart traffic steering, enable real-time QoS adjustment, even the dynamic policy controls. On the go, the AI can monitor, connect, and then make decisions or change the configurations of a network on the real time based on network requirements or specific use cases it monitors. Then predictive handover optimization. We understand that suddenly there is a lot of traffic and handover optimization, network optimization, or load optimization on the core is required. That's where our agentic AI plays a key role. And then today, when we talk about advanced feature set, location-based services, resource allocation, and how the various use cases over the location services are being deployed actively, and how we optimize that through our agentic AI. We'll talk about these in the further detailed slides. So today we all understand that when we have to deploy private 5G network, there are multiple ways we deploy a private 5G network. Either you have a standard private 5G core. When I talk about core, both control plane and a user plane deployed at an enterprise network, it becomes a standalone private 5G network where you deploy core network functionalities, various network functions of 5G core, then UPF for data plane, and then multiple RAN across the network for a seamless 5G coverage. Now, when we have to deploy an end-to-end private 5G network, there is a considerable cost for enterprises, and not all enterprises across the globe are willing to bear that cost in comparison to various technologies. So as per 3GPP, this local breakout edge UPF deployment is a feature set where you can deploy RAN and the UPF, and you can integrate or use the existing public carrier core network, the control plane, for all the control plane services or the signaling services. And at the enterprise, you have the full control of the data plane or all the user data traversing through the network. So through this, if you look at this architecture, we have integrated the private network or enterprise network to an existing public network, where a seamless mobility is also achieved from public network to a enterprise network. So a user which was in a public network moves in a coverage where enterprise network is there. It connects to the enterprise RAN, and then through the RAN, packet starts traversing through the new UPF instead of going through a UPF TSA primary anchor. Now, based on the various policies, what type of data needs to be routed either through a local network of enterprise or through a public network are defined. Typically, once you reach a enterprise network, all the data packets are routed through a local network of enterprise. The benefit is once you are within an enterprise private network, you are behind the enterprise firewall. So they control all the packets which are going out, which enhances the security. So security is not compromised. We are only using the control plane of the public network, but all the data plane, all the user plane packets are routed to the enterprise. However, achieving this, which from a customer perspective, from an enterprise perspective, they save an enormous amount of money in the deployment. Yes, they have to engage a public network integration with them. But however, in terms of deployment, it's a simpler deployment. You deploy RAN and you have that full-fledged enterprise UPF deployed. Another way to look at it as the same architecture, same. If we have a multiple geographies where you deploy a public-private 5G network at one place, and you have to expand that private 5G network to another office in another city, there won't be a seamless mobility. But other than mobility, once a user reaches within the second enterprise office within a different geography, different city, they would seamlessly be connected with the private core control plane deployed at first city, main city, and then through this UPF deployed at the edge, all the traffic can be routed to the office locally at the new geography. So that seamless mobility, seamless deployment across geographies are fully supported. So when we talk about 5G core or the 5G network deployment, we know that the IP address allocation happens at the 5G control plane. SMF and WAN plays a key role for assigning an IP address or PDU, PDU IP address, sorry, to the end user devices, be it a mobile phone or end user, be it a 5G enabled camera, AGVs or robotics from here. But if I'm talking about private 5G, currently, if I talk about Ethernet, all the IP address the IP address allocations are happening at an existing application server, which is running at an enterprise level. And all the enterprises are looking towards either replacing a Wi-Fi network or cabling or network Ethernet ports towards a 5G network with an enhanced feature set. That's where this Ethernet PDU feature sets come into play. Through this, we enable a transparent bridge mode in the 5G node. With this feature set, the 5G node, 5G network becomes a transparent bridge or a simple packet pipe for end user. And through this, the end device, which is AGV, 5G camera, robotic arm, mobile, or any other device at enterprises, can directly connect or get an IP address allocation from the existing application server. And through this, we can bypass the entire ecosystem of the 5G core DHCP planning or the IP address allocation happening at the network. The end user gets an IP from the application itself. That's a key feature set requirement when you have to deploy the private 5G network across smart factories or various other specific use cases across. So I think slicing is something very interesting today. A lot of use cases are being deployed across multiple slices. And there are multiple ways we can have the slicing deployed across the core. We can have one slices, multiple DNNs, and multiple UPF sessions. So we have distributed or kind of tried to explain it in three kind of scenarios here, where you look at the first one, where one user can connect to a single UPF, but however, there are two DNNs. A single UPF is managing two different PDU sessions and two DN network. Now, with the two DNN network, if end customer has different requirements, if the user wants a two different session, one is an enterprise network and one is internet capability, you can bifurcate. UPF have the capability to bifurcate those sessions into two different DNN according to policy. So that feature set is also supported. Now take this example in the next one or the middle one, where the same user needs to have a clear-cut bifurcation of the data packet or multiple DNNs, where they don't want to use the same UPF, same hardware, and have the different allocation. So here, even the same control plane, you can run a different multiple UPFs. One goes to a voice call IMS, and one goes to a primarily enterprise IoT, enterprise applications. That feature sets where two UPFs are deployed across the same control plane with different UPF managing different PDU sessions with different DNNs, which enables high security, enables reliability, and various other feature sets. That's also supported with our 5G core solution. Now, the third one is another interesting use case. So there are multiple users. They want to have different use case. First user wants to access internet, but it's a single private network. That's where you can have the some part of single standards, single control plane for all the users. However, you bifurcate the control plane and a user plane into different functions. So here we have mentioned that different policies, SMF and slices are connected with one UPF, which manages the internet DNN. So there are two edge UPFs here. They are managing, they have their own SMF or IP address allocation. They are managing their two different DNNs and different PDU sessions. So that flexibility is also there. The third one, you can even assume that both the SMF PCF are located with the control plane or can be located geographically located other than the control plane. So that flexibility in our entire architecture is there. So the reason we are trying to showcase this slide here is, even though it's a 5G control plane, all the network functions are fully seamlessly like a micro-based architecture, but they have the flexibility to be deployed across the globe, across the use cases for specific customer requirements. I hope that makes sense. So now we move into the 5G core key services. For this slide deck, I'll hand over to Ankur to talk about the key feature sets and how we have enabled AI and what are the AI enabled features we have developed in our 5G core. Over to you, Ankur. Thank you.
Thanks, Gaurav. If we can move to next slide. Okay, so thanks, Gaurav, for summarizing 5G core as 3GPP specification. Here, what I'll summarize is, when we talk about 5G core key services, there are total 5 kind of services we get out of 5G core. Number 1 being data routing from your user equipment or industrial floor, factory floor, to your remote location. There are different kind of services which are location-based services on the basis of location of a particular user equipment. There are different services being offered by 5G. Subscriber management, where we do PDU session quality of service management, and mobility management, where handover and paging and mobile registration services are present. And fifth is policy control. So you can have different policy for different kind of users, for different slice, for different type of devices. Like a camera device will have a different policy than industrial robot. That all control can be managed by 5G core. So these are the 5 areas. Now we'll go deep into each and every area, like how AI is enabling different use cases. So this is the mobility management, the one functionality which 5G core provides. The main challenges there are when we talk about any enterprise network or industrial network. So frequent handover, when we talk about dense movement and very high movement, handover is a challenge. Then high latency in terms of real-time applications. Next is quality of service control. So whenever user is moving from area A to area B, there might be different QoS profile available, and that adds up to the latency and user experience getting different. Now, resource allocation suffers due to congestion in high mobility scenario. Now, when we talk about how AI helps us in handling these challenges, first is mobility pattern prediction. Let's take an example, a person A or a robotic device available on factory floor moves only from location A to location B, or it goes to one floor to or equipment moves from one floor to second floor. So I know the pattern, I can predict the pattern with the help of AI on the basis of user movement, and accordingly I can plan network resources and handover management, which is the second use case. So we can actually predict and we can use this mobility pattern in order to have a better planning for a particular device. Next use case is traffic forecasting. Like in case of high mobility area, let's say uh, some kind of a stadium, there will be specific pattern when high mobility will be available or a lot of users will be available. So adjustment of network capacity, I can predict on the basis of traffic forecasting, depending upon different network situations. On the basis of fourth use cases, with the help of AI, we can actually manage the slice admission for a particular user on the basis of their speed, application type, and bandwidth need. Let's say we have a video specific slice where a camera device is giving me video data. Now, whenever this user is getting into a sustenance mode or upgrade mode, I don't need a very high uplink policy in that case. So I can move it to a different network slice when there is a maintenance activity. And as soon as it comes into operation, I can again bring back to the different network slice. So it can, on the basis of users of a particular device, it can actually dynamically move from one slice to another slice. So overall user experience becomes better with the help of AI in case of mobility. Okay, this is where the subscriber management, so session management. So main challenges in this area is where we need help is fixed policies. So on the basis of user behavior, there is no change in the policy if we talk about 5G core without AI. And different, identifying different fraud situation, that is also very difficult in case of traditional rule-based subscriber management. Now, when we talk about subscriber management, how AI helps us in getting a better user experiences. So on the basis of subscriber behavior, depending upon at a particular time slice, how user is interacting with network, I can actually change the service profile for that user. Let's say a user, when he is traveling from location A to location B, it is using video services. But when it goes to office, it is enterprise uses. So depending upon the data uses and mobility pattern, I can change the quality of service for that particular user. So it gives, on the basis of the type of application being used, I can use dynamic quality of service enforcement. In case of fraud detection, what happens is that since I know the user default uses, I can actually figure out, or I can predict what kind of a anomaly is being seen in the either signaling plane or data plane activity. And that information is being collected by the 5G core in the with the help of AI. And depending upon the policy, we can actually configure what kind of action we require to take in case of any anomaly. Next is billing or, yeah, thank you. So in case of a user uses, we can actually predict what kind of a suggestion is required for billing or plan suggestion. We can actually, on the basis of uses, we can actually predict and suggest for the operator or network operator that this kind of a QoS policy should be enforced for this particular user. Data routing. As Gaurav has also mentioned, traffic steering is one use case. With the help of AI, we continuously monitor the congestion at the between RAN and UPF on the uplink side, and on the DN to UPF ping time. On the basis of that latency, congestion, and jitter, we can take optimal data path for a particular kind of traffic, and that gives a overall better, and we take help of uplink classifier also in this particular case for doing a traffic steering.
Ankur, can I just interrupt for a moment?
Yeah.
I see somebody's raised their hand. Can I request you to put your query in the Q&A section? We'll take it up in the end for sure. Thanks. Thanks, Ankur.
Okay. QoS aware traffic routing. When we talk about a particular use case or traffic profile, on the basis of service need, whether it is a EMBB slice, ultra low latency, or MMTC, we can actually predict the pattern of traffic and do a traffic routing on the basis of kind of deployment or service need. Let's say a particular user is requesting for a ultra low latency, type of service. In that case, we can, if there is a deployment in such a way that there are different UPF for different slices, we can actually select a UPF which is giving the best latency numbers. So overall, it will improve the user experience and SLA management for a particular service type or slice with the help of AI. Yes, policy control. Okay, so if we talk about policy control without AI, there is no dynamic policy in that case. Now, on the basis of congestion, I can have a different policy for same user in order to give unified service to all the users, and I can decongest with the help of routing it to a different segment of the network. All that can be done on the basis of dynamic policy control, which is being taken into account, which will take care congestion, overall latency, as well as other network KPI. So policy control becomes a little better, which is reactive to the network, and that helps in giving a better service. Intelligent traffic steering policies we have touched upon in the traffic routing part. Personalized network policies in case of subscriber behavior, your customer profile, you can have different kind of SLA for a particular user, and all that policy can be controlled by AI-based decision and AI-based data models. Can you go back on the slide, please? Yeah. Okay. So last point is where we can actually predict the policy. Like when we have a network pattern, we can actually forecast what kind of a subscriber experience will be there. And depending upon that feedback, we can plan our policy or replan our network on the basis of SLA requirements. Now we can move to the next slide. Location-based service. Now this is another interesting use case where positioning, typically, if we talk about positioning, is done through GPS, cellular, and Wi-Fi overall in the network. However, in this case, what we do is we predict or we take into account all three kind of location, and then we do estimation on the basis of what is the best possibility of the location for a particular subscriber. Location aware network resource allocation. This is again network planning. It helps in the network planning depending upon the user profile as well as where the location of a particular user is. We can plan the resources and we can do admission control accordingly on the segment of the network. Context aware, again, user preferences, your location history and behavioral data is used to give a model or user experience digital twin, which is used in case of if there is any other policy update required for a particular user. Okay, over to you, Gaurav.
Thanks, Ankur. Thanks for the insightful, detailed AI-powered feature set of our core. So when we talk about use cases, so in terms of AI, Ankur has touched a lot about in terms of optimization, the use cases. So primarily we have spoken about network optimizations, dynamic network slicing, so and then predictive maintenance, automated fraud detection. These would be this fraud detection could be something very interesting for various use cases. Then secure data sharing. So for various use cases, if I talk about MNO deployments or rather the private 5G, security plays a key role. And the way AI would enable the security in the feature sets or the networks is very interesting. Uh, in terms of enterprise application, we just run through various use cases where edge deployment, local breakout, or factory floor automation in terms of AGV, AMR deployment, camera deployment over a 5G network where this Ethernet PDU feature sets are required, where the existing infrastructure is required. Those feature sets are required. And how the agentic AI we are building in a solution, the automation flavor we are building, those network efficiencies, the OpEx part in terms of if various use cases or various deployments needs a higher network reliability. Primarily, if I talk about enterprises, smart factories, where the network reliability plays a key role. Even few minutes of downtime plays a can be very expensive for that organization. So all those network reliability improvements using AI feature sets, how agentic AI run through the network, gather all the KPIs, gather the data from all the network functions, then keeps on monitoring and learning. So here, learning plays a key role. Typically, when we talk about training data, the solution we have our in-house training data set, we have the synthetic data, and then we deploy the network on the customer deployments where it runs through the initial period of training set and then keeps on optimizing. There are various, I mean, I don't want to go into the how AI learns, improves itself, but the same way we have this AI flavor built into the 5G core. And then if I talk about in terms of how this AI flavor today building into the current 5G network and how the future proof networks are being built, where the future plan for 6G network is coming into play. That's a key innovation or the key pillar we are working towards, where the entire solution we are building today is future ready for our further future deployment across few years or down the line few years from a 6G perspective. I think we have touched base a lot about our 5G core, and Rohina, maybe we should give an opportunity to the participants to ask some questions.
Yes, Gaurav. Thank you, Gaurav and Ankur. This was a very comprehensive walkthrough of Amantya's 5G solution. So we'll now open the floor to questions. Please share them in the Q&A window and we'll take them up one by one. Okay, I see we have a few already. So I'll take up the first question. What is the role of NWDAF in your 5G solution?
Yeah, I'll take this up.
Okay.
So what we are using in case of AI is NWDAF only. So we are doing all event exposure and data like QoS monitoring is one use case I'll touch upon. So this latency, congestion, and end-to-end delay we are taking with the help of UPF QoS monitoring, and that data is fed into NWDAF. Analytic engine takes care of the data training and all that, data model training. So we are essentially actually, Tomer, using the NWDAF.
Okay. The second question that I see is, how does the solution help in OpEx savings? Gaurav, would you like to take that up?
Yeah, thanks. I briefly touched upon it in our webinar itself. But so when we talk about OpEx savings, each deployment, each customer there are two ways of spending. One is the CapEx initial deployment and then the OpEx one. So today, when we have to deploy a network and manage it, that's where the key OpEx comes into play. So when you deploy a 5G network, the way 5G is already designed is highly reliable networks. But when we talk about network reliability of 5 nines, where if I talk about smart factory or anywhere, uh, each downtime is resulting in a lot of losses for the organization. So when we talk about OPEX saving and how AI brings into the higher network reliability, uh, the AI, the agentic AI we have built in the core, it gathers all the information real time. Let me put it that way, that the network we have, it thinks for itself. So there is a network which the network we are trying to build, optimize, can predict any issue happening before it happens. There are various parameters we gather from the network, from the RAN, from core, from the network functions, which allows us to maintain a data and which allows us to predict to where the network issue could happen. And on its own, it may even try to resolve before it happens. Or it may share alarms to the customer so they can plan for a downtime accordingly and then fix it. This when the sounds of it talks of it thinks it seems like it's a very small steps, but when you have to deploy a network, these small steps plays a key role in the savings for end customer.
I'll just add on this part. So let's take an example of you have orchestration, smart orchestration, where you can have NF getting instantiated on the basis of need. Now, whenever there is a slice SLA which is not getting met, we do spawn a particular UPF just to maintain that SLA. The moment it is, my first UPF is in decongested state, I take out this new UPF and I move all the sessions to the existing previous UPF. So my network operational cost is dynamically growing and going down on the basis of network uses. So that is how it's not a overcommissioned network plan. It will be scaling up and down on the basis of need. And this helps in OPEX reduction.
Right. Um, Coming to the next question, how do you ensure all data remains secure?
I'll take this up. So there are two kind of securities when we talk about. First is subscriber data. Since this 5G core, our Amantya 5G core is going to be deployed in the customer premises, so subscriber data specific security is maintained by the customer policies only. Now, another aspect of security is my AI is aware about your network uses, your subscriber pattern, and all the other interesting and intelligent data points. Now this becomes, and a lot of our customers are asking this question, so thanks for asking this part. uh, what happens is we train our data, AI engine with the basic data set we have made here. After that, your network NWDAF or AI model is getting trained by your data, and that is in your premise. So it's always safe. We never know what data you have trained your AI model with, and it is with you only. So we never get to know. So if a customer is keeping its data secure, it is secure.
Right. I have an interesting question here. All core vendors state similar value propositions. What differentiates you? I think we should definitely take this up.
So that's a very interesting question, and I think differentiation plays a key role across the industry. Uh, when you talk about state the similar value, I agree with you that all the core feature set, the primary 3GPP compliance, and all the standard feature sets are same. How do we differentiate ourselves in terms of the way we are building AI into it, the way we are building automation into it, the way we have integrating agentic AI into the solution? Uh, these things are very small, but when we look at the the way network architectures are growing, the way the 6G network architectures are building, the way we are building our solution to be future proof. Today, the solution we are designing are looking towards fewer down the line. And even if I talk about today's network, the deployments, the customer we are talking to, we support all the use cases in terms of a forward-looking approach. Even though they may not be asking the solutions, the feature sets, advanced feature sets we are building today, but down the line, when we talk to our customers, they agree and understand that there are various use cases where AI will play a key role. The way we are differentiating ourselves, another is the way the entire architecture we are building is kind of a seamless open architecture. We are not limiting ourselves to be building a end-to-end core node or end-to-end core network. For us, each network function in itself is a product of ours, and all the network function combined together is builds a 5G core. From our perspective, we are looking towards a future-proof, open, interoperable network functions, network node 5G core solution with a built of touch of AI, how the network optimizes, how network handles itself for customers. I hope that helps. And there are a lot of features we gone through which we believe a lot of companies have not yet started and we have already implemented. So there are some differentiations. We are already ahead from the competitors.
Yeah, I'll just add on to this. So it's a very interesting question, and I will take a stab on this from the development point. So when we talk about different core vendor or all core vendor, they have a legacy of 3G, 4G, 5G. Now, what they are doing is they are trying to change their existing product line to 5G use cases. So they have a legacy they need to support. When we have started developing this, some years back, we don't have a legacy. So it is actually built only for 5G. That is one thing. I'll give you an example of it. Our UPF can run on ARM, even on Intel Atom, or Intel i7, or Intel Xeon, because we don't have any legacy feature or legacy protocol. It is purpose built only for 5G use case. And that is one of our differentiators. So we can scale up from any point, scale down to any point, or we can scale up to any point. This is probably from the implementation point of view, or agility, because we don't have any legacy product to support in our 5G.
Well, I think between Gaurav and Ankur, this question's been answered very well. Moving on, do you support NTN?
So I think just now Ankur spoke about that the way we are architecture is we support multiple platforms, ARM, Intel based. When we talk about NTN deployment, the deployments are the satellite itself, how the network, the core networks are to be deployed even on the satellite itself, or some part of the core network deployed on the satellite and some part on the ground station. And like we spoke about earlier, the entire architecture we are designing is flexible, where multiple nodes can be deployed anywhere. Primarily talking about NTN, yes, in simple words, we support NTN deployments. The core network is NTN compliant because the way compute requirement on satellite is very low, or rather the compute should be very low. So the way we have architecture, when Ankur was talking about ARM, so the way our core is designed, it is highly scalable. We can support very low number of users on a very single core on ARM platform to be deployed on NTN. So all those functionalities, when we design our core or the solution, we take care of all the use cases. And NTN is a very interesting use case. We are working with customers for the deployment of solutions on the primarily LEO OEMs.
Right. How does Amantya's core handle network optimization?
So one use case I have just explained, where NF, orchestration, or your operational network dimensioning is totally reactive to the network condition and traffic forecasting. That is how we optimize. And depending upon the network SLA or service level SLA for a slice or a particular subscriber, that is also optimized with the help of AI. and we maintain that, whatever is the SLA promised to a particular user, that is being serviced. Okay, anomaly detection. So anomaly detection, first of all, is the traffic pattern. Second is, I'll take a use case where sometime back in India, we figured out a particular mobile equipment manufacturer was using same identity for all the mobile phones. So we detect anomaly in the signaling as well as user plane. User plane anomaly is based on DPI and traffic pattern, and that anomaly, we have models where we predict this is an anomaly or not, and they are quite flexible in terms of taking or modifying a decision. So with the help of API, you can control whether it is an anomaly or a expected behavior, and that's how we actually take care of the anomaly part at signaling as well as data plane.
Yes. What is seamless handover? Can we use AI in 4G network?
Okay. So seamless handover is handover between networks. When I say networks, be it 5G to 5G, radio to radio, traditional handovers. Now, in terms of your next question about 4G enablement of 4G in AI, so the way AI is built into the solutions is that the core network functions, even in today's time, can give the data output. How AI, agentic AI, or the AI solution built into the core can go gather them data, monitor them, learn from them, and implement changes. That's a separate platform. So when I talk about 4G network, if the 4G network functions or the 4G network nodes are able to provide network-wide network reports, which an AI, agentic AI, or any AI platform can go read, learn, then yes, you can enable that in the 4G network itself. However, you need to have planned the network development of the 4G node and the agentic AI together to build into it. I mean, we are more focused on 5G. Our 5G solutions, where the end-to-end solution we are designing is built and optimized towards that, where how the entire network deployment or even the single network function with agentic AI is enabled into it.
And one aspect, we do support handover in 5G to 4G in NSA mode also. So we have that capability, Satya.
Right. I think we have addressed most of the questions. I think, and if there are any remaining questions, we'll respond to them offline. So that brings us to the end of today's webinar. Just I think Gaurav wants to.
Yeah, just before the closure, I just want to add that anybody who's visiting MWC Barcelona next month, we have a booth at we are there at a booth 3, stand 5A3, hall 5. So feel free to drop by to our booth. We'll be happy to chat in detail on all our solutions, not just core, but our testing platforms and all of the solutions we are bringing. So we love to have a face-to-face connect with you all. Feel free to book a meeting using our link on a website or on our LinkedIn platform. Thanks, Ravina.
Right. Thanks, Gaurav. You did that for me. I was going to announce that later. Thank you, Gaurav and Ankur. Very valuable session. And thank you all for attending. We hope you found this session insightful as well. Feel free to reach out to us at connect@amantyatech.com or the phone numbers that we'll be sharing with the session recording. If you have any further questions or would like more details. And as Gaurav said, we are going to be there at MWC from March 3rd to 6th. Just to let you know, we will be at booth number 3, stand 5A83 in hall 5. We are going to be sharing all these details with you. So if you are headed that way, please do drop in. We would be delighted to take you through our solutions. And we'll be sharing all these details with you with the recording. So stay tuned for more updates from Amantya, and we look forward to seeing you guys soon. Thank you.
Thank you.
Thanks.